Okay. The topic that I'm going to discuss or share with you is about uniform arithmetic gradient. Um, an arithmetic gradient series is a cash flow series that either increases or decreases by a constant amount each period. For example, maintenance and repair expenses on specific equipment or property may increase by a relatively constant amount each period. The amount of change, whether increase or decrease, is called the gradient. So, example, suppose that the maintenance expense on a certain machine is 1,000 pesos at the end of the first year and increasing at a constant rate of 300 pesos each year for the next 4 years. So if you are going to plot this one on the cash flow diagram, okay, yan isa, no? 1,000 at the end of the first year, and then increase siya by 300 for the next 4 years. So on the second year, it's 1,300, and then for the third year, mag-add 300, and so with the fourth and the fifth year. So for 4 years, ga-increase siya of 300 from 1,000 to 1,3 to 1,619, and then 2,200. So the problem now is, how are we going to get the equivalent value of P or F, okay, given this type of series? So this cash flow may be resolved into two components. So this is the original cash flow. I-reverse na to. Ipot na to sa upper na portion sa diagram. This is the original cash flow, and we're going to resolve this one into two components. We have n equal to 5 periods. Now, the first component is a uniform and equal payment na series or an ordinary annuity. No? Like for this one, nasa common na 1,000. So, i-separate na to ang 1,000. This one. Okay. Equal payment na series. So, A equals 1,000, N equal to 5. It's easy to get the present worth of the ordinary annuity. We denote it as P sub A. We already have discussed this one. Or there's already a video on ordinary annuity. Just watched it. Yeah. The other component is the difference, like 1,000 minus 1,000. So for the first year, 0, and then for the second year, 1,3 minus 1,000 is 300. Or simply, we denote 300 as our gradient G. So for the first year, 0, 1,000 minus 1,000. The second year, we have G. Positive dyan, no? Okay, from 1,000 to 1,300 nun. And then we have 2G, 600 is 2 times 300, and 3G, and then 4G. With G equal to 300, N equal to 5. And then we get the present worth of this gradient. Okay, denoted as P sub G. So based from this diagram, we can say that P is equal to the present worth of this cash flow is equal to P sub A plus P sub G. So in symbol, we have this one. P sub A is equal to A times P given A, I percent N. Present worth factor, uniform series, present worth factor, plus the second component, G, times this factor, P given G, I percent N. Arithmetic gradient present worth factor also. Okay. So uniform gradient. Well, this one uniform series, arithmetic gradient, and uniform series here. So our focus now is on this one. How do we solve for P sa gradient na component? So finding P when G is given. Okay. So consider everything as F and then we get the value of P. Now, except, di ba, kay zero man eh. So we start with G times, we use the compound interest na formula. To solve for F, it's solve for P rather. P is equal to F times 1 plus I raised to N. So for this one, it's G times 1 plus I raised to negative 2. And then plus 2G times 1 plus I raised to negative 3 and so on until the last payment. So we have this one. For period 2, period 3, period 4, and so on. Now, we can see from this one, these terms now, like this one, if the exponent is 4, the coefficient of G is 3. If the exponent of 3, the coefficient of G is 2. Therefore, if our exponent is N, then the coefficient is N minus 1. So, these are our last two terms. If the exponent is N, the coefficient is N minus 1. And then mag-decrease kag 1. Okay? N minus 1, this one N minus 2 na kay minus 1. Mo niya general na equation to find P given ang G. Now, next is we multiply this equation by 1 plus I. Okay. So, P times 1 plus I and all the terms sa right side. Na pag i-multiply siya 1 plus I, the exponent is positive 1. So, negative 2 plus 1, this becomes negative 1. This one, it's negative 2, negative 3. And then plus 1, it's negative 2, no? Ay, ano man siya? If we remove the parenthesis, it's negative N plus 1. Okay? Negative N plus 1. Now, mag-add kag 1, it becomes negative N plus 2. And then, you extract negative, it becomes negative parenthesis N minus 2. Okay. Now, for this one, we add 1, it's negative N plus 1. But if we extract the negative sign, and then parenthesis, it's negative, parenthesis, it's N minus 1 na yun. Okay, ang positive, pag extract sa negative, negative ang result. So the result is this. So, okay, if we remove the parenthesis, negative N plus 1 man. So correct na kay mag-add man tag 1. Okay, next is we subtract this one. Okay. Second minus first. So we subtract the first equation from the second. So second minus first equation. And ma-observe dire na if we combine terms with similar exponent like this one, negative 2, negative 2, 2G minus G, the result is G. G and then 1 plus I raised to negative 2. Same with this one, with exponent negative 3, 3G minus 2G, G tanan. No? And then ang next term man is 4G times 1 plus I raised to negative 4. Okay? 4G minus 3G, G na lang. Okay, so makancel ang, so, if we combine from 2G minus G, G lang result. And sa left side, P times 1 plus I, that's P plus PI minus P, and the result is PI. So left and right, this is the result. P times I. Okay, this one. So G times 1 plus I raised to negative 1. And then for negative 2 na exponent, 2G minus G na lang. Negative 3 na exponent, 3G minus 2G na lang. And so on. Okay. So ang makombine na ng n minus 2 is ang term before ani. Nantay n minus 3 g1 plus I raised to negative quantity n minus 2. So i-combine ni mo sad niyang iyang result. And then this one and this one pag i-subtract ni mo g sad ang result. And then kini wala man siya partner. So minus. Okay, second term. Second na one. Baga subtrahin. Subtrahin. Okay. So it's n minus 1 g. Now, if we break this one into two terms, negative n times g times 1 plus I raised to negative n. Negative and negative 1 becomes positive. So positive g 1 plus I times I raised to negative n. So the simplified equation is this. So we have plus g and then negative in g, this one, times 1 plus I raised to negative n. Now, okay, if you group this one, tanan all nanay g, ana, it's actually ordinary annuity. If you plot this one sa cash flow diagram, the result is this. Eh? Like g times 1 plus I raised to negative 1, g times 1 plus I raised to negative 2, and so on. Up to n. G times 1 plus I raised to negative n. Ordinary annuity. Okay? I-recall na to sa ordinary annuity. This is the cash flow diagram sa ordinary annuity. And get the present worth of each individual payment. Mo man siya. Okay, so ordinary annuity. And the formula of P for ordinary annuity is this one. Or this one. Bali, if you put this one sa denominator, converting this one to positive exponent, it becomes 1 over 1 plus I raised to n. And then you get the LCD, the result is this. Okay, let's use this expression of P. So PI is equal to the formula of P and minus this one. Okay, this is for ordinary annuity. And the annuity is G. And then the second term, extract G and then N, 1 plus I raised to negative N, put sa denominator, positive na dayan ng exponent. And the next step is to extract G, common factor, and then extract also 1 plus I raised to N, common siya, i-extract ni mo 1 over 1 plus I raised to n, di ba? So 1 plus I raised to n, and then extract also g. Okay, what is left sa first term is 1 plus I raised to n minus 1 over I. Sa second term, it's only negative n. Kaya ma-extract ang g, ma-extract ang 1 over 1 plus I raised to n. Combined with I sa left side, P is equal to i-divide ang I sa right side. The final equation is this, or formula of P is this. Okay, so therefore, the factor P given GI percent N is equal to this one. Okay. The term in brackets is the P given G I percent N. This one, the term in brackets. Or linear gradient series present worth factor. So this is for the G component. Okay. And for the total present worth, i-add pa ang present worth sa first component katong ordinary annuity. Okay, let us solve this problem. Kim deposits her annual bonus into a savings account that pays 7% interest compounded annually. The size of her bonus increases by 3,000 pesos each year, and the initial bonus is 10,000 pesos. Determine how much will be in the account immediately after the fifth deposit. Okay. Let's draw the cash flow diagram. Initial is 10,000. Okay. And then increases by 3,000 each year. Okay. And sa fifth deposit, the fifth deposit is 22,000. No? 10 to 13, 16, and 19, 22,000. So what is asked is how much will be in the account immediately after the fifth deposit. So meaning if but we only have our formula, we only have the formula of P. So first, we get the value of P, and then after that, convert na to F using compound interest na formula. Okay. So this is the formula of P. First component, ordinary annuity, and then second component sa gradient na component, sa gradient part. I is 7%, our A is 10,000, and our G is 3,000. Positive, no? Kaya nag-increase man. So, substitute sa formula. Okay. And the present worth is this one, 63,941.97. Okay, so after P, we get the value of F, or the value of the account immediately after the first payment, first fifth deposit. So to solve for F, we use this formula. F is equal to P times 1 plus I raised to N. And then substitute the value of P, and mao ni ang kining amount ng value sa deposit, all of the 5 deposits, based sa year 5. Another one. The maintenance expense on a machine is expected to be 10,000 pesos during the first year, and to increase 1,000 pesos each year for the following 6 years. What present sum of money should be set aside now to pay for the required maintenance expenses over the 6-year period? Assume 8% compound interest per year. So 10,000 during the first year, and then mo increase sa 1,000 sa succeeding year. So 11, 12, 13, up to the one for a 6-year period. And the question is, what present sum of money should be set aside? P. So basic na cash flow diagram sa uniform gradient, linear gradient. So we just use the formula. Our I is 8%. Our A is 10,000. and our G is 1,000. And then substitute, direct substitution. This is the present sum of money. Now, to double check this value, you can analyze this one as each of these payments considered as F, and then you get the value of P. So 10,000 times 1 plus I raised to negative 1 plus 11,000 times 1 plus I raised to negative 2 up to 15,000. And ma-check ni mo na the value of P is equal to this one, 56,752.07. Third problem. What is the equal payment series for 10 years that is equivalent to a payment series starting with 20,000 at the end of the first year and decreasing by 1,000 each year over 10 years? Interest is 7% compounded annually. Okay. So for 10 years, we have this. The original cash flow is this. 10,000 at the end of 20,000 at the end of the first year, and then get decrease by 1,000 over 14 years. So 19 and then 18, 17, 16, 15, 14, 13, 12, 11. So this is the original cash flow. The question is, what is the equal payment series for 10 years that is equivalent to this series? So what we're going to do is to convert this one into equal payment series. This one, equal na siya sa this one. So what's the value of A? What's the value of A? Equivalent ani na series. So what we are going to do is to solve for P for this series and then use this value of P there. So given P, you solve for A. So ordinary annuity na tayo na formula. So first, solve for P for this gradient na series and then equate this P sa present world sa equal payment na series. So solve for P of gradient series. Our A is 20,000 and our G is negative 1,000. Okay, decreasing man by 1,000. Our I is 7%. Right? So A is 20,000, G 7, I is 7%. Our gradient is negative 1,000. And the value of P is this, 112,756.08. Equate this one sa ordinary annuity. So solve for A of equal payment series given P of gradient series. We use this formula. P sa ordinary annuity. And then compute this one. After that, you divide ang value there sa left side and we have this P. 16,053.93. Okay. So that's it. I hope that you have learned something from this video. Thank you for watching.